So here is the list of features that Java 20 is going to include. These are the big ones, and as you can see, this is kind of interesting feature because many of these are just updates on the earlier ones that I have already covered here. So you have seen already Vector API. I made a video on that one. You have seen record patterns, pattern matching for switch, foreign function and memory API, virtual threads and structured concurrency, Project Loom features. So if you have been watching videos on my channel, you already know what's coming up there. I'm not going to elaborate deeply today. I'll just give you highlights in case you haven't seen the videos. But pretty big stuff coming up. So they are just updated. So we get second preview, fifth incubator, etc. But only new feature coming up here today that wasn't in the earlier versions of Java is scoped values. So I wanted to dive a little bit in here and tell you what's the problem statement that this one is fixing, what it's going to do, give you a highlight of what's going on there. And on the other ones, I will just update briefly why they are here, what they will unlock. I want to point out that the major features are not the only thing changing. So if I dive a little bit deeper here, here is Java 20 Early Access Release Notes. These are not worth going one by one through. But just wanted to point out that there will be API changes, deprecations taking place. So there is pretty long list of tinier changes. I'll drop all these links below my video. So if you want, you can read these. But to keep the video snappy, I'm not going to cover these ones. So instead, let's talk about scoped values. I think that's a great place to start. Scoped values, what's the problem statement? Well, this is part of Project Loom. Project Loom is aiming to increase Java's parallel features and capabilities while making them a little bit simpler to tap into. So that's why we have the virtual threads, and I earlier made a video on how you can use that to launch like million parallel threads doing some things. So we are expecting to get a lot more parallelism in the future. That's where the Moore's law now living. Instead of getting more clock cycles to processors, we are getting more cores, more threads, and much more virtual threading. So that's the way to handle kind of more computing capabilities. Okay. Now, scoped values is answer to the question, what when you have those million virtual threads going on, what if you like to share some information between those threads? So if there is something that you need pretty much everywhere. So for sake of pretending something, let's say that we have something like user identity, user principal. If you have guest user and admin user, it would kind of be fun if we manage to keep them and their privileges separate everywhere. So if I'm opening database access at some tier, it would not happen with kind of maximum permissions everywhere. For the guest, I probably want a bit more limited permissions for the system. Let's say it might be on database level, it might be on some other level. This example in the Java 20 documentation is covering database level. So we would like to open database with different privileges depending on how you logged in, right? Pretty typical problem. Now, once we have those million threads to keep track of, where do we like to pass this identity information? So we need to somehow see what's the role or identity of the user. So one way to do that, obviously, is to pass it in always as a parameter. So you can have function parameters, everything as a parameter. That's okay. However, that would leave your APIs kind of, they might get a little bit crowded, because if it's something you need everywhere, then every API is going to have that parameter. And that might be okay. If you like functional style, that might be quite good for you. It definitely makes things easier to test. But in some cases, it might not be. And those cases, people have been using thread local variables. They have been around for quite a long time, since Java 1.2. remember when we were dealing with the minor increments. Now we are at Java 20, long way ahead. Anyways, here is their example from the Oracle documentation. So we have the server, we have database access tier, and we are passing information across those classes using a thread local variable. It's final static variable, and inside this variable we are pushing information here. And then somewhere else, while we are executing within same thread, we are able then to kind of dig in the thread local value and get the original value out in a thread safe manner. Yes, and we are going to be able to not pollute the API by putting those parameters here. Again, a matter of kind of taste, whether you call it pollution or way to go, but that's not topic today. So we are trying to replace thread local with the scope values. And why? Well, thread local used to have a lot of kind of problems. I think one of the huge ones was the garbage collection. So at what point are you able to release it? It could lead to memory leak, especially when you have a huge number of parallelism going on. Because once you store it, you need to yourself remember how to kind of remove it from the thread local. But thread local was a little bit similar. It was a handle to a value that is thread local, so every thread has their own copy. Here is a long list of problems. It's kind of unconstrained mutability, so you can change it in the child threads everywhere, and that makes it a little bit iffy. You need to kind of know how to use it right, or you get a lot of problems. Unbounded lifetime means once you create it, if you want to remove it, you have to somehow reset it. And then that's where the memory leaks live also. Those people who were really good at this kind of stuff and really precise managed to handle this in a good sense, often based on bad experiences. Then they fix it, and then they have a good solution. But problem is that not all teams are kind of expert level parallelism people, and then this is very dangerous thing because it can lead to very difficult problems. Okay, so there's a new kind of incubator level initiative for the scoped values. It begins a little bit same here, but then we have something very different going on here. There's a little bit better example. Let's walk through this one just quickly, and I think by the end of this you know about scoped values as much as I do. And remember, this is incubator level stuff, so it's like brainstorming phase, and it's expected that it can change. But it's available. You can get the early access Java 20 version, and then you can play with it already, if this is something that interests you. Okay, we have server class. Server class is here figuring out if user is admin or guest. Then we are storing that role information here as an example. We are storing it in the scoped value. Scoped value at this level looks a little bit like thread local. We are using final static kind of modifiers to store it. It's convenient. So this is not the value. This is the handle to a place where we can get the thread scoped value. And by the way, that's immutable now. So here we have scoped value where. This is the first change. We are not explicitly setting for the principal a new value. What we are doing is we are making a scope. Where is defining a scope, and within that scope, the value is going to be this principal. And within that scope, when I'm running my code here, within that scope, I have that thread scoped value available. And when the scope ends, the value is free for garbage collection. So this is fairly simple way to do the same things than thread local used to do, but with a little bit less room on shooting yourself to your leg. So here you can see the kind of receiving end is pretty much as before. So we are not passing this value as parameter. We get it from the static value. I'm simply saying get, and the mechanism is taking care that I get my thread's version of the value. scoped and immutable. So I cannot really set it. I cannot really alter it or change it. I just get it through this scoped reference setting here. Okay. So this is not the easiest thing to explain, but I'm hoping I managed to do that. If I did, if this made any sense to you, then please give me that thumbs up right now below the video, just to let me know that I managed to do it, because this is not an easy example to go through. But hopefully you got it, and what I'm aiming here for is that you would be able to understand if this applies to something that you are working with or not. And if it does, then what's the benefit? Where is the value here? And as I mentioned, remember that this might very easily change, but this is probably something you get with Java 20 release. And when it's actually released, it might then look a little bit different. So, what else is new? Let's cover the other ones, but a lot faster. I'm not going to elaborate right now, but I will gladly come back around Java 21 when these are a little bit more kind of ready and done. So I will gladly come back and explain those again, all of these in depth. But for today, let's try to give you the value, what's behind there, and is it relevant for you? Vector API. Vector API is nothing new in programming world. So it's an API that used to be available in low-level languages mostly, but it makes some types of calculations with huge mass of data much more efficient. So you are able to do some things that you delegate to processor level execution instead of managing the mathematics in Java. So we have an API for that. I have covered that on a video in my channel, but it's highly special purpose, so it's not probably going to do much for you unless you hit that specific need. So you have a rather simple set of calculations to be performed for a huge amount of data. You might encounter use cases for this one if you do computer gaming. So if you have to calculate some bitmaps, for example, very rapidly, you need that power. Or if you do machine learning, that's another case where you might be dealing with huge set of data and might need to do some kind of transformation or refining. Data processing, machine learning, computer games are areas where I can find use cases for this one. So it's been available for other languages for quite some time, but now we are getting it to Java, and it's in 5th incubator, or so still kind of figuring out what's the best API. Then we have some fun stuff that's been around for quite some time, and I think these are quite mature and will probably be part of Java 21 pretty surely. I have covered these happily on my channel because these are for everybody. So if you are using switch cases, if you are using records, we are now getting a little bit better tools, more intuitive tools, more fun tools, in other words. So record patterns is simply patterns for record management. So you're easily able to take a record and even deconstruct it here. And then we have pattern matching for switch, which is going to go a bit deeper than what we already have. So instead of just matching the pattern, we're able to deconstruct things and get the values and use them in our code. So as I said, these are pretty much for everybody. Keep an eye on these. It's like language improvements, so you are able to work in a happier way in future Java. Then we have foreign function and memory API, and this JEP is about kind of replacement for JNI. So you're, as the name implies, you are going to get an API that allows you to execute code that's not a native Java code, and you are able to do that more safely than with JNI. And then we have straight access to memory, a little bit better access to memory than before. So native level is kind of the keyword here, and this has went through many iterations. JNI is kind of number one iteration. And then we got, I think this was called something else when it began, but now the foreign function and memory API is the name of it. It's again at preview level, so I might expect that to be released as part of Java 21. Then the rest two ones are about Project Loom, so parallelism goodies. And I have covered these in depth on my channel as well. I dropped the links below the video. But virtual threads are at second preview. Virtual threads are the component that lets you get more out of your physical threads. So it's a kind of better mechanism for running million threads in parallel without really needing to kind of tap into million hardware threads. So we have kind of had this unofficially done on implementation level earlier, but now it would be more like standard level in Java. And it's very powerful mechanism to make it easier for programmers to do this billion threads level stuff. And related to that, we have structured concurrency, which is kind of a little bit better API for concurrency programming. Java's got way too many concurrency mechanisms by this day. So I have been tempted to once perhaps do a video starting from Java 1.0 threads and going onwards, but that is very kind of heavy work to do. There's so much stuff, and I would like to use good examples of all these. So let me know in the comment section if you would like that video, just going through all the history, more than 20 years of history, how the parallelism has evolved. But on the other hand, that's not very relevant for people who are not coding parallelism. And if you are doing server-side Java, you are typically inside the parallelism mechanism already. So you just have to know what not to do. And then you are not going to be managing million threads yourself, because the server environment is going to do that for you. So if you are working on that level, let's just say that people who are writing the server mechanisms and creating the Lambda function rotors, for example, they will have more powerful tools available, and you don't have to worry so much. You just get more execution power, more performance. There is to be expected. Okay.